maybe this helps. What? Terry?
24.
That's true. Can you think of one that's even smaller? We'll do 24. We can use 24. So what's that mean? That means we're going to change 5/12 to some, I don't like that color. To something 24s. Okay? Terry chose 24 because 12 can multiply to get 24 and 3 can multiply to get by something to get 24. We cannot just plop the 5 and the 2 down there because you can't say, it's like what I just started with. When I said 5/12 of you are wearing fleeces, and then I join you with another class of 12 and I say now how many are wearing fleeces, if I rename it, you wouldn't say still 5 out of 24 because the whole scenario changed. We had 5 compared to 24 or 12, so something else is going to compare to 24 because we're getting larger. So how do you get the top number? Caleb?
So for 12, for 12 and 5, you would make, so you multiply the 12 times 2, so you also have to multiply the 5 times 2
Okay.
to get 24, to get 10.
Okay, hang on a second. Which I'm going to call these equivalent fractions. Have you guys ever heard of that term?
You never have.
You never have?
Yes, we did. Yes, we did.
Okay. To rename fractions or get equivalent fractions, get a common denominator. And what Caleb just started explaining was what you do to the bottom. How does that finish? What you do to the bottom. How come you're not finishing with me? What you do to the bottom.
You stay to the bottom. Both sides.
You do. Okay. Well, you're telling me what you remember. That's quite all
You do
right.
to the bottom, you do to the top.
Yes.
I know.
Leo, are you writing this down? David, are you writing this down? Natalia.
I thought whenever, I thought you only had the 2 top numbers. I thought you only had one of the 2. I thought whenever the bottom stays the same.
We're not there yet. You're correct. Right now, all we're doing is renaming them so that we can add them. Because 5/12 plus 2/3, we can't do anything with. We got to rename them, then we're going to do what you just described. Okay? So what Caleb said was 12 times 2 is 24. So 5 times 2 is 10. Do you know why this works? Because what you're really multiplying 5/12 by is 1. Isn't 2 over 2 1? Do you see that? Anything over itself is 1. So if I'm doing something to the top and the same thing to the bottom, I'm really multiplying 5/12 by 1. And multiplying by 1 doesn't change the value of it. Okay? So 12 times 2 is 24, 5 times 2 is 10. 3 times 8 is 24, 2 times 8 is 16. So if I had, let's think of, what's easier, pizza or candy?
Candy.
Okay, or candy. So you take those big old, like, Hershey bars. I don't know, those chocolate Hershey bars are about like that big. Okay, so if I have 12 pieces and I eat 5 of those 12, it's the same as if I cut them in half and I have 24 pieces and I ate 10, right? Because those are equivalent fractions. If I had a pizza in 3 pieces and I ate 2 of them, it's the same as if that pizza was in 24 and I ate 16 of them. getting hungry. So now, let's keep going with this. Number 3, okay, to rename friend, what you do the bottom, I'm gonna get the top. Okay, hang on. I wish there was a good way to abbreviate denominator, but I'm not for right now. How about if I can spell it right? It's not denominator. Denominator. So this is what Natalia was saying. Right? So one more time, if I have 10 of something, and I add 16 more of that something, then I get 26 of that something, which is kind of weird here, right? Because it seems more, the top is more than the bottom, but that's okay. What would you get when you reduce 26 24ths? Victor, what's 26 24ths reduced? Not the question I'm asking. If I keep it a fraction, what is it reduced to? How can I divide both of those by 2? Okay. So what's it reduced to?
6 over 12.
I'll take 12. That's 26 divided by 2. 26 cut in half. 13. Now, this is going to be something that it takes quite a while to get used to. If I want things in reduced form, that's reduced. I don't need to make it a mixed number. A mixed number is a different form of that number, but it's not simplified over the other, okay? So I'm gonna leave it like that. Is it equal to 1 and 1/12? Yes. And we'll go more into that to make sure you know that process, but one thing at a time. Back here. Oops. Yeah. Was there another number that I could have used besides 24? Was there another one I could have used besides 24? Sebastian? 12. I could have used 12, couldn't I? Always look for that, because if one of them goes into the other, then I don't have to change 2 fractions, I only have to change 1. And if 5/12 plus 2/3. And guess what? If I do always find the least common denominator, times 4, I don't have to reduce at the end. See, I get the answer right away. So it is helpful to try to find the smallest one that it goes into, but if you reduce at the end, it's okay. You could have thought 36, you could have thought 120, there's endless amount of numbers it could be. That's the easy, quickest one. Okay, what if it was mixed numbers? Let's have somebody on this side of the room tell me what I should be doing. Leah, what's a common denominator I could use this time? Look up here. denominators are 4 and 5. What's the least common denominator? 4, I'm not asking which one is smallest. I'm asking what's the smallest number that both 4 and 5 go into? Think of your multiples. And I know everybody gets confused, I'm talking to all of you, between multiples and factors. Denominators are always multiples. They're always gonna get bigger. Multiples of 3 are 6, 9, 12, etc. Factors are what builds them up. So, Leah, back to you. 20. Good job. Yeah.
Natalia said they leave at 10:40.
Oh, they do?
I'm not sure.
Yeah, it's on the schedule.
Yeah, it's on the schedule. They have ELA too.
9:45, 10:20.
I thought we had.
Okay, tabling this.